So in this session, what we'll be trying to do is solve numerical problem based on cubic unit cells. Okay, we'll be trying to see numerical problem based on formula of a solid and the other type of numerical problems which we face in cubic unit cell. Okay, which will be very helpful for your board examination as well as for the entrance examination. Okay, so let us try to take few examples and understand it, how to solve it. Okay, so this is our first question. A compound of X and Y, okay, a compound is formed by an element X and Y, crystallizes in which Y occupies the corner and X occupy the alternate faces of the cube. Find the formula of the compound. So what they are giving us is, they are giving us a unit cell, okay, and they have told us that where the atom is. There are two atoms, X and Y. Y is occupying in the corners and X is on the alternate faces of the cube. So let me just first try to picturize it. Okay, in your exam, whenever you encounter this kind of formula based question, always try to picturize it. You can draw in your rough. So that is what I'll be trying to do. Okay, so I'll just take a cube. Okay, just a minute. Okay, so let me take a cube. Okay, so we have a cube. Now in this cube or in this unit cell, where are just a minute. Okay, in this, where is our Y? Okay, the Y is present in the corner. The Y is present in the corner. So that is what they have told us. So Y is present in the corner. Now the next thing is that where is X? Now this you have to understand. X occupies alternate face of the cube. So alternate, basically opposite. So if one X is here, then alternate means leave this and the next will be over here. So in this face and in this face. Okay, that means left and right. But now you cannot say, okay, this, the front and the back is also alternate and the top and the bottom is also alternate. So what will happen if I'll put on top, then this top and this particular side is not alternate, they become adjacent. Okay, so when they say X occupies alternate face of the cube, you can have only one pair of alternate face of the cube. Remember that. You cannot have all the faces. If you put in any of other faces now, what will happen? This particular face where you have put X and the other face where you will put will be adjacent. So you can have only one pair of alternate face. Okay, so that is this. We are taking left and right. So now the question is how to actually go for such kind of problem. So now the number of atoms of Y, let's say, will be equal to, now how many number of atoms of Y you will have? Now Y, how many we have? You have 8 because it is present in the 8 corners, right? Into, now the question is how much each of this Y remaining in the corner will contribute towards the unit cell. Will it contribute wholly? No, we know that it contributes only 1, 8. So you have 8 number of Y and multiplied by 1 by 8. So how many atoms you have? You have only 1 atom of Y, or that means in that particular cell you have only 1 Y. Now similarly, number of atoms of X. Now how many number of atoms of X we have? 2. You can see clearly, but the question is, will it contribute totally? No. Whenever a atom is present in the face, what is the contribution? Its contribution is half. So how many number of atoms of X I have? 1. So therefore the ratio of X and Y will be equal to 1:1. Now always remember that the ratio in which the atoms are present in a particular unit cell is the ratio of the stoichiometric or the stoichiometry of that compound. Okay, means the stoichiometry of that compound and the ratio of the atoms which is present in a unit cell is always same. So that means the ratio of X and Y is 1:1. That means the compound, the stoichiometry of the compound is also 1:1. Therefore, formula of the solid or the compound will be equal to X. How many times? 1 time, and Y. So the formula of the compound is XY. Okay, so that is how actually we solve this kind of problems. Okay, so whenever you get this kind of problem, the first thing what you need to do is try to picturize it. Okay, that way it will be very easy. You'll know that where the atoms are present. Okay, then you will know the correct number of atoms. Once you know the correct number of atoms, the only thing what you need to know is what is their contribution. Okay, so once you know the contribution of the atoms in the corners, in the face, and in the body, then you just need to multiply with that. Whatever is the ratio you get of that particular element, how many number of element is present, 1, 2, 3, 4, the ratio in which they are present in a unit cell is nothing but the ratio of the compound. Okay, or the ratio in which they are present in a particular compound. So the formula of this particular solid is XY. Okay, so that is how actually we understand this particular example. Okay, so let us go for the next. Okay, so our next problem is a similar one, but here we have not X and Y, but we have the real atoms. So an alloy. Okay, so there is an alloy of gold and cadmium. Okay, so we have made an alloy of gold and cadmium, and it crystallizes in a cubic structure. Okay, so it crystallizes in a cubic structure. It can be any cubic structure in which gold atom occupy the corner and cadmium atom fit into the face center. Assign the formula of this alloy. So again, a similar problem. So first, let us draw a cube. Always do that. Okay, in your exam, first you always draw a cube and try to put the atoms in their position. Okay, in this way you'll never make a mistake. Okay, but when you try to imagine it, okay, sometimes you can make a mistake, but when you draw it, whatever you are actually imagining, you are drawing it. So if there is any mistake in your imagination also, you will be able to find it out correctly. Okay, otherwise sometimes in imagination we make mistake. Okay, in process of doing fast, we lose the entire marks. So what they are saying is structure where gold atom occupies the corner. So gold atom, gold is AU. So let me write AU in the corners. Okay, so gold atom is present in the corner. AU, 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 AU. Over here it's AU and it's AU. So in the corners we have gold, and cadmium atom fits into the face center. So cadmium atom is actually in the face center. So how many face center will have? 6 face center. So CD, 2, 3, 4, and the top one 5, and this front one, I hope you can see that, 6. Okay, so we have 1, 2, 3, 4, 5, and 6. Okay, in the 6th phase center, the cadmium atom is present. Now, what we need to do is calculate how many number of atoms of gold and cadmium actually is present. So, number of AU atom. So, how many number of AU atom is present? AU, how many are there? 8. What is the contribution of each gold atom? 1 by 8. I hope everyone can understand this. Why it is 1 by 8? Because gold is present in the corner. Okay, so it will be equal to 1. Okay, so I hope that's fine for everyone. Then number of cadmium atom will be equal to how many number of cadmium atom you have? The number of cadmium atom is 6 because there are 6 phase center. Into what is the contribution of each atom in the phase? It is half. Each atom in the phase contributes half to the unit cell. So it will be 3, half of 6. So the number of cadmium atom is 3 and the number of gold atom is 1. So therefore, the ratio of AU is to CD will be 1:3. So what will be the formula? Therefore, formula of the alloy will be equal to gold, how many? AU, only 1, and cadmium, how many? 3 times. So CD3. So that is your formula, AU CD3. So that is how we solve the problem based on formula. Okay, so if they give you anywhere in the unit cell, that is how actually we solve it. Okay, depending upon where the particle is present, you calculate the number. So knowing the contribution of particles in various position in a unit cell is very important for such kind of problems. Okay, so let us go for the next. Okay, so now what do we have over here is a type of problem, again very common in your board as well as in entrance examinations also. So what they are asking us in this particular example is calculate the approximate number of unit cells. So over here we have to calculate the number of unit cells present in 1 gram of gold. So they have given us 1 gram of gold. What we have to do is we have to find out that in 1 gram of gold, how many unit cells are present. So what they have given us is, given that gold crystallizes in face-centered cubic lattice. So it is already given that gold is crystallizing in face-centered cubic lattice. Okay, that is FCC. So how to approach this? And they have given the atomic mass of gold also, that is 197 U. Now, in such problem or in this problem, what we have to use is the concept or the mole concept. So let me start with this. I hope all of you can understand. 1 mole of gold. So if I take 1 mole of gold, I hope everyone can understand that it's 197 gram. That is what we know, is it not? 1 gram of any substance is equal to gram molecular mass or gram atomic mass of that particular substance. That is what we call as mole concept. Okay, so if you are feeling any doubt in this, that, or if you have forgotten what you have understood or what you have learned in mole concept, okay, there is one video, okay, in the YouTube channel. You please watch that particular video in mole concept. Okay, you will get the proper concept of mole. Okay, so always remember that whenever we have gram atomic mass and gram molecular mass, it is always is equal to 1 mole. Okay, and 1 mole is equal to 6.023 into 10 to the power 23 atoms of gold. I hope everyone is okay with that, right? 1 mole is equal to nothing but Avogadro's number. So after this, what we can do now is, so what they are trying to say is, from this, what we can understand is 197 gram of gold is equal to or contains 6.023 into 10 to the power 23 atoms. Okay. But the big question is, do we have 197 gram? No, we don't have 197 gram. How much we have given is 1 gram. So if 197 contains Avogadro's number, 1 gram of gold will contain how much? I hope everyone knows this. It is unitary method. So 6.023 into 10 to the power 23 by 197. Okay. So I hope it's fine. So now, if that is the case, so if it is this many number of atoms which we have, so the actual number of atom which is given to us is this. Okay. So now the question is, what we need to find is not the number of atoms, but the unit cell. Now, what they have given is, they have given us face-centered cubic unit cell as FCC, face-centered cubic unit cell, contains how many atoms? 4 atoms. Yes, we have learned that one FCC unit cell contains 4 atoms, right? So that means if I talk about one unit cell, how many number of atoms will be there? The number of atoms in one unit cell will be 4. So what I can say, that means 4 atoms will be equal to 1 unit cell. Is it not? In FCC, 4 atoms is present in 1 unit cell. That means 4 atoms makes 1 unit cell. How many number of atoms you have? You have this many number of atoms. So this many number of atoms will make how many unit cell? So 6.023 into 10 to the power 23 by 197 will make how many actually unit cell? So that will be equal to 6.023 into 10 to the power 23 by 197 divided by 4. So it will be multiplied by 4. Okay, I hope it's okay for everyone. So that is what is the basic concept. So first, we try to find out the number of atoms in 1 gram of gold, okay, or 1 gram of any substance, or whatever gram of any substance given. Once we are done with that, we need to know that what type of unit cell it forms. We know that it forms face-centered. So face-centered means 4 atoms. That means 1 unit cell is equal to 4 atoms. That means 4 atoms makes 1 unit cell. So this many atoms will form how many? Divided by 4. So if you do that, the answer which you'll get is 7.64 into 10 to the power 20 unit cells. Okay, so this type of problems are very common in your board examinations, okay, as well as in the entrance examinations. Okay, so that is how actually we solve problems based on the unit cells.